Okay, for section 2.1, we'll look at functions. The objectives for this section will be to first do point-by-point plotting of equations in two variables. Next, give and apply the definition of a function. Identify the domain and range of a function. Use function notation and solve applications. Okay, for the first part here, it says graphing an equation. To sketch the graph of an equation in x and y, we need to find the ordered pair that solve the equation and plot the ordered pair on a grid. This process is called point-by-point plotting. So, for example, we have the equation y equals x squared minus 2. In order to graph this function, we need to determine the ordered pair that solve this equation. Okay, so the first thing we'll do is choose some values for x. Plug those values into the function or evaluate the function for those x values to obtain y. Once we've obtained y, we'll have our 2 points x and y, which represent our ordered pair. X, y will give us our coordinate for that corresponding x value. Okay, so notice these x values here. Let's lock this. Okay, which range from a -3 to a +2. So we'll plug these values into the equation y equals x squared minus 2 to find our corresponding y values. Okay, so from the table here, I'm going to put an X through this because they actually have a plus in between. So we're actually finding x squared plus 2 for all of those. So we'll need to find another column for y. Okay, and since y is found from the equation y equals x squared minus 2, in order to find the corresponding y values, we'll plug in the value for x, square that quantity, and subtract 2 from it to find our corresponding y. Okay, so for the first one, if I have x equals -3, I have x squared, which is -3 squared minus 2. And so -3 squared is +9, -3 times -3 minus 2, which is 7. And so our ordered pair for this will be a -3, +7. Okay, so let's make this last column our ordered pair. Our XY coordinates. Okay, next we have a -2. So if I take -2 squared and subtract 2, I'll get -2 squared, which is 4 minus 2. I'll have 2. And so the ordered pair for this, when x is -2, y is +2. Okay. For the next one, we have a -1. So -1 squared minus 2 is a -1 minus 2, which is a -1. So when x is -1, y is -1. Okay. Here we have x equals 0. So I have 0 squared minus 2 equals -2. So when x is 0, y is -2. Okay. 1 squared minus 2. And so we'll get 1 minus 2, which is -1. So when x is equal to 1, y is -1. Okay. And then for the last one, here we have x is 2. So we have 2 squared minus 2, which is 4 minus 2. And so in this case here, I have the point 2, 2. Okay, and so if we were to graph these points on a Cartesian coordinate plane here. Okay. And so if we go back, let's go back. We have the parabola shown here. Okay, and notice they make a smooth curve. You can also check this in your calculator. So let's lock this. If you go in your calculator and type y equals so click the point y equals and then type in the function x squared, which is going to be, in order to get the x, you'll choose the xt theta n button. So you'll choose x And then to choose the squared button, choose this button x squared. And then we'll do minus 2. Okay. And then once you do this, if you choose the graph button, okay, you'll see the graph there. Okay, let's look at the next slide. Okay, so in this slide we have the definition of a function. And the first point says the previous graph is the graph of a function. The idea of a function is this: a correspondence between two sets D and R, which represent the domain and the range, such that each element in the first set, so each element in the domain, for each element in the domain, there exists one and only one element in the range. So I only have one x corresponding to one y value. If an x corresponds to more than one y value, it does not represent a function. Okay. The second point says the first set is called the domain, and the set of the corresponding elements in the second set is called the range. Okay. For example, the cost of a pizza C is related to the size of the pizza. A 10-inch diameter pizza costs $9, while a 16-inch diameter pizza costs $12. Okay, so we can visualize the relationship here. Okay, it says here, you can visualize a function by the following diagram, which shows a correspondence between two sets. D, the domain of the function, which gives the diameter of pizzas, and R, the range of the function, which gives the cost of the pizzas. Okay, so notice here that for each x value, 10, 12, and 16, we have one corresponding value for each of those of one corresponding y value. 9, 10, and 12. So this represents a function. Okay. And this is just a function specified by equations. So the first point says, if in an equation in two variables we get exactly one output for each input, then the equation specifies a function. The graph of such a function is just the graph of the specifying equation. Point 2, if we get more than one output for a given input, the equation does not specify a function. So we should receive one output for every input, not two outputs for every one input. Okay? If we get one output for each input, then it specifies a function. If I input a value and I get two values back, that does not represent a function. Okay? Okay, so notice here we have the equation y equals x squared minus 2. When we plugged in a value for x, say -2, we had a -2 squared minus 2, which was 4 minus 2. By plugging in a -2, we got an output of a +2, which represented one value. So for our corresponding x of a -2, we got one corresponding y value. Okay, so if we were to draw a diagram, here, let's lock this again. Okay, so here, let's draw one here. We'll put our domain values here and our range values here. Okay. So our domain values from the table before was a -3, -2, -1, 0, 1, 2. And our corresponding y values were 7, 2, -1, -2, -1, and +2. Okay, so notice here that each corresponding value of x corresponds to exactly one y value. So each domain element corresponds to exactly one or one and only one range value. So -3 corresponds to 7, -2 corresponds to 2, -1 corresponds to -1, 0 corresponds to -2, and then in the case here we have a -1 and a +2 repeated. You do not want to repeat values, so I'm going to erase these two. Okay. And so we have 1 corresponding to a -1 and 2 corresponding to a +2. Okay. So notice here we're only focused on the domain elements. Notice each domain element goes out to one and only one y value. And so in this case here, y equals x squared minus 2 specifies a function because each element in my domain corresponds to one and only one element in my range. Now, it doesn't matter if the range receives two different values. The main thing is we're focused on the domain portion only and making sure each element there only goes out to one y value. Okay? Okay, next we have the vertical line test. It says if you have the graph of an equation, there's an easy way to determine if it is a graph of a function. It is called a vertical line test. So, in order to determine if a graph of a function, if the graph represents a function, we should be able to use the vertical line test. Okay, and it says here if any vertical line passes through two or more points on the graph of an equation, then the equation does not specify a function. Okay, so if we look here, we have two graphs. Notice we have a red vertical line drawn through each graph, and for the first one, let's lock this. Okay, for the first one, it crosses 2 points. Okay, so here we say this graph is not the graph of a function because you can draw a vertical line and it crosses it twice. But for the next graph here, we have a vertical line drawn and it only crosses the graph once. So because a vertical line crosses only once, this graph does represent a function. Okay, so it's easy to determine a function from a graph. You'll just draw a vertical line. If it crosses the graph at only 1 point, that just means each element in the domain corresponds to one and only one element in the range, and that does represent a function. Okay, for function notation, it says here, function notation is used to describe functions. The variable y will now be called f of x. So just know here that y is the same thing as a function of x. Okay, and it is a function of x because the way we find y is we plug in some value of x into the function, evaluate it, and simplify, and we get our value of y. Okay, and so just make sure you're reading this as f of x and not f times x. Okay, and so here we've only replaced y with f of x. Okay, so when we see f of -3, what f of -3 means is that I want to evaluate the function for -3 to determine the corresponding y value. So f of -3 means the corresponding value of y when x equals -3. Okay, or it means to find the corresponding value of y. Okay, so if I see f of -3, that means I'm going to evaluate my function f of x equals x squared minus 3 by plugging in -3 into the function and evaluating it. Okay, so here if I have an x squared and I'm evaluating f at x, I need to plug in the value of x, which is -3, in for the x within the equation. Okay, and so that gives us the 9 minus 2, which is 7. So f of -3 is equal to 7, but what that means is that when x is -3, our corresponding y is 7. Okay, and it also represents the ordered pair -3, 7. Okay, so here we have a few more examples. If we have the function f of x equals the square root of 3x minus 2, and we evaluate it for f of 2, f of a, and f of 6 plus 8, that means we're going to plug in these values into the corresponding x values. Okay, so if I have f of 2, I'm going to replace 2 with the x in the equation given in the box. Okay, so I have the square root of 3 times 2 minus 2. I have the square root of 6 minus 2, which is the square root of 4, which gives me 2. Okay, and so just remember that just means when x is 2, y is equal to 2, and it also represents the ordered pair 2, 2. Okay. Next we have a. When x is equal to a, when I plug that into my equation here in the box, I'm going to replace x with a. And so I have the square root of 3a minus 2. So my corresponding y value when x is equal to a is going to be the expression, the square root of 3a minus 2. Okay. And then for the last part here, I have 6 plus h. So when x is 6 plus h, my corresponding value of y is found by plugging in the quantity 6 plus h in where the x was. And so I'll have 3 times 6, which is 18, plus 3 times h, 3h. So I get 18 plus 3h minus 2. If I simplify that, 18 minus 2 gives me 16. And so my corresponding y value is the square root of 16 plus 3h. Okay, so whenever you're asked to evaluate a function or to use function notation to determine what f of 2, f of a, or f of 6 plus h means, we're just going to substitute those expressions or those quantities or expressions into the equation for the x or the unknown variable shown. Okay. Okay. Next we have 0. So here I have f of 0, which means to evaluate the function for 0 or replace x with 0 and determine our corresponding value of y. So when we do so, f of 0 is equal to the square root of 3 times 0 minus 2. And when we simplify that, 3 times 0 is just 0. So we end up with the square root of a negative 2. If you remember this from algebra, this was called an imaginary number or a complex number. Okay, so in this case here, this is going to be considered a non-real number. So when we get something like this, we'll just call it non-real. Okay, and so when x is equal to 0, our function is not defined for a real value. Okay, so this brings us to the domain of a function. Okay. Notice here for f of x equals the square root of 3x minus 2, we have restrictions for any output. So in this case here, whenever you have a radical, the quantity under the radical has to be a positive, or it can be 0 or any positive value. Okay, because anything negative will give us an imaginary number or a non-real number. So we say anytime we have a radical, the expression under the radical, 3x minus 2, has to be greater than or equal to 0, making it either 0 or non-negative. And so if we solve this inequality here, we get 3x is greater than or equal to positive 2. And then if we divide by 3, we get x is greater than or equal to 2/3. This will give us our domain for our rational function or a radical function. Okay, and so here I'll say the domain for f of x is going to be 2/3 to infinity. So it can be any value including 2/3 up to a positive infinity. Okay, or you can give the inequality here. Okay, so it says here, therefore the domain of our function is the set of real numbers that are greater than or equal to 2/3. Okay, let's look at another one. Here it says define the domain of the function. We have f of x is equal to the square root of 1/2 x minus 4. Okay, so in this case here, in order to determine the domain of this function, we need to make sure the expression under the radical is non-negative. Okay, and so we'll say 1/2 x minus 4 is greater than or equal to 0, and we'll solve for this inequality to determine the domain of this function. Okay, so we'll add 4, and so we'll get 1/2 x, negative 4 plus 4 cancels, is greater than or equal to 4. And then you can divide by 1/2 on both sides or multiply by the reciprocal, which is 2/1. Okay, so either one gives you the same thing. Okay, so on the left side, we get 1 times x, which is just going to be x, is greater than or equal to 4 times 2, which is 8 over 1, or just 8. So our domain is the set of all x such that x is greater than or equal to 8. Or we can say the domain is 8 to infinity. So it can be 8 or any value greater than 8. Okay. Okay, here we have a rational function. Okay, so if you remember from algebra here, if we divide by 0, we get an undefined expression. Okay, so if we get f of x, and it can be any number, so any number over 0 is undefined. So this is also non-real. So when we have a rational expression, we want to make sure the expression here, when solved for x, does not give us a value of 0. So we'll say 3x minus 5 cannot be 0 in this case. And so you can solve this, or you can just solve for x. And we get 3x cannot be equal to 5. If we divide by 3, we get x cannot equal to 5/3. Okay? Because in this case here, if I were to plug in 5/3 into this equation, so here I say I have f of 5/3 is equal to 1 over 3 times 5/3 minus 5. 5/3 times 3, the 3's cancel, and I end up with 1 over 5 minus 5, which is 1 over 0. And the function is not defined for that. So for 5/3, I get 1 over 0, which is undefined. Okay? So my only issue with a rational equation or a rational function is when the denominator is equal to 0. Okay? So it can be the set of all x except for the value of 5/3 in this case. And so we'll say here, the domain is the set of all x such that x does not equal to 5/3. Or if we give the interval notation here, we can say all values from negative infinity to 5/3, in close parentheses, union from 5/3 to infinity. Okay, so that's how you exclude it. If you were to sketch this on a number line and say this point represented 5/3, we can say everything up to 5/3, not including it, and beyond 5/3, and we'll exclude it with the parentheses. So the parentheses here must be drawn, and then we unify them with the union, or you can do a comma. Okay, so those are our domain, or our two different ways to represent the domain of this rational function. Okay, so it says here the function is defined for all values of x except for whether the denominator of the fraction is 0. This means all real numbers x except for 5/3. Okay, now let's look at the mathematical model shown here. Okay, it says here the price demand function for a company is given by p of x equal to 1,000 minus 5x, which the domain is given by x greater than or equal to 0 or less than or equal to 100. Okay, so the number of items represented will range from 0 to 100. And p of x represents the price of the item. Determine the revenue function and find the revenue generated if 50 items are sold. So the revenue is found by, and we'll call this R of x, the price of the item times the number of items sold. Okay, so if you notice here, we're given a price function above, 1,000 minus 5x, and so our revenue function is going to be found by 1,000 minus 5x times the number of items shown times x. Okay, so we can say revenue is equal to 1,000 minus 5x times x. Or if we distribute the x, we can say that revenue is equal to 1,000x minus 5x squared. Okay, so it doesn't matter which equation you use. You can use whichever one. Okay. So that's the revenue function, this or this. Okay. And then it says to find the revenue generated if 50 items are sold. So if 50 items are sold, I'm going to replace the number of items with X. Okay, so notice here, or you can use the other equation. Okay, so we have R of 50 is equal to 1,000 minus 5 times 50 times 50. Okay, and so if we were to type this in, we get 1,000. And if you type it in, make sure you type it in exactly how it looks. So we have a parentheses first, 1,000 minus 5 parentheses 50 or times 50. And then close the parentheses for that quantity times another 50. And so that gives us 37,500. So the revenue for 37,500 items sold is going to be, so the revenue for 50 items sold is going to be 37,500. Okay. So if we wanted to do a corresponding values of the ordered pair, we have 50, 37, 5, or 50 and 37,500. Okay. Okay, so it shows the same thing here, and it says that the domain of the function has already been specified. So we were told initially that our range, or our number of items, range from 0 to 100. Okay, next let's look at break-even and profit-loss analysis. The first point, it says any manufacturing company has costs C and revenue R. The company will have a loss if the revenue is less than the cost. The company will break even if the revenue and the cost equal. And the company will have profit if the revenue is greater than the cost. Costs include fixed costs such as plant overhead and etc. And variable costs, which are dependent on the number of items produced. So if you notice here, we have an equation. C is equal to A plus BX. In which case our fixed cost is going to represent A and our variable cost is going to represent BX. Okay, so I'm going to rewrite this. C equal to A plus BX. This will represent our fixed cost, and this will represent our variable cost. Which depends on the number of items produced. Okay. Next, we have the price-demand functions usually determined by our financial departments play an important role in profit-loss analysis. Notice here we have the equation P equals to M minus NX, and X is the number of items that can be sold at a price, at P price dollars per item. Okay. Next, we have the revenue function, which is R. R just represents the number of items sold times the price per item. So we have XP, or X times P, representing the price, in which case P equals M minus N. So we have X times M minus NX, just replacing P with the expression that it equals. Okay. And then for the profit, we have the profit is equal to R minus C. And in some cases, you'll see the profit, P is a function of X, equal to R as a function of X minus C as a function of X. Okay. And notice here for the revenue, we just have the number of items produced times the price, and then minus the cost, which is going to be minus the fixed cost plus the variable cost. Okay. So I'll go ahead and rewrite that. M minus NX minus A plus BX. Okay. So an example, it says a company manufactures notebook computers. Its marketing research department has determined that the data is modeled by the price demand function. So we have P of X is equal to 2,000 minus 60x, and this is when x is greater than or equal to 1 or less than or equal to 25. So the number of items produced range between 1 and 25 in the thousands. So between 1,000 and 25,000. Okay. What is the company's revenue function and what is its domain? So our domain is already given. The domain is the set of all x such that x is greater than or equal to 1 or less than or equal to 25, in which case 1 and 25 represent thousands. Or if you're giving the interval notation, we have 1 to 25, and the square brackets just represent that those two values are included. Okay, so we already had that part first. Now let's look at the revenue. The revenue is equal to the number of items times the price per item. So the number of items sold times the price per item. Let me back up. Okay, so we have x times 2,000 minus 60x. That will give us our revenue function. Okay, so I'll go ahead and just rewrite it here. Okay, so here's the revenue, or you can give the revenue as 2,000x minus 60x squared. So our domain or our revenue function is given in the boxes, okay? And our domain is given by either one. Whoops. Let me lock this. Okay. By either this or this. And in this case here, since it's in thousands, I'm going to specify. So let's put in thousands. So in thousands. Okay. Okay, next let's look at the profit function. Okay. It says here the financial department for the company in the preceding problem has established the following cost function for producing and selling X thousand notebook computers. So the cost function C of X is equal to 4,000 plus 500X, where X is in thousands of dollars. Okay. Write a profit function for producing and selling X thousand notebook computers and indicate the domain and range of this function. Okay. So the domain and range will stay the same. We'll come back to that in a second. But our our profit function is found by, so let's write this. The profit as a function of X is equal to the revenue of a function minus the cost. Okay. And so I'll write the equations that we had earlier. The price demand function was given as P of X equal to 2,000 minus 60x. We found our revenue function from that, which was just equal to the number of items sold times the price demand. So we had x minus 60x. And so revenue was 2,000x minus 60. Whoops. So 60x squared. Okay. So in order to give our profit function, we're going to replace the revenue function with 2,000x minus 60x squared, and then we want to subtract the cost function, which is given here as the fixed cost of 4,000 plus the variable cost of 500 times x. Okay, and so since I'm subtracting that whole quantity, I'm going to put it in parentheses so that I don't forget to distribute the negative or subtract each term within that function. So we have 4,000 plus 500 x. Okay, so if we simplify here, we have 2,000x minus 60x squared minus 4,000 minus 500x. Okay, and so our profit function it's going to be negative 60x squared. And if we combine like terms here, a 2000x minus 500x will be plus 1500x minus 4000. Okay, so here we have our price function, or our profit, not price. Okay, so let's put our profit function, and then our domain is just going to be the same as before. So x is going to be greater than or equal to 1 and less than or equal to 25,000 items in the thousands. Oh, it was 25. So let's erase this. Okay, so x is greater than or equal to 1 and less than or equal to 25. And this x is represented in thousands. Okay, so this is our domain. And we'll do it in set builder notation. Okay, and I'll go ahead and add the other one. Or the domain is given as 1 to 25 in thousands. So notice the last slide here, we have the graph shown. And if you want to graph this in the calculator and get the exact same thing, here I'm going to put the steps down. So make sure when you're graphing, you choose the y equals button, and then you're going to type in the profit function. Okay. Okay, so you should see y equals negative 60 x squared plus 1,500 minus 4,000. Okay, and then you can graph it. But if you graph it, it'll be in the standard window or whatever window you left it in. Okay, so if you want it to look like this window, then you'll need to put in the domain restriction for this, which ranges from 1 to 25. Okay, so we'll select the window button. Okay, and once you select window, here we're going to type in values for the X min, the X max, and the X scale. Okay, so for the X minimum, we know that that's going to be 1. For the X max, that's going to be 25. Okay, here if we want to determine the scale, let me erase this part of the graph, and we'll count the tick marks. Okay, so if I know it ranges from 1 to 25, and I count the tick marks in between, so starting at 0, I count 1, 2, 3, 4, 5. So if I divide 25 by 5, I know the scale is going to be in increments of 5. Okay, for the Y min, Y max, and the Y scale. Okay, I want to count from 0 here. So I have 0, 1, 2, 3, 4, 5. And this is going to 5,000. So if I divide 5,000 by the increments of 5, I know my scale is going to be 1,000. And so my minimum, starting at the bottom, will be from 0 to my top of 5,000. And it looks like it's a little more than that. So if you want, you can put 6,000. I'd probably put 6,000. Okay, and then you'll graph it. And so then you should get a graph that looks like the graph shown here. Okay, that'll be all for section 2.1. Make sure you go to MyLabs Plus and complete your homework.